Welcome to the Machine Learning Pioneer interview series presented by Microsoft. My name is Xiaopeng and I lead Cloud and AI Go-to-Market in Microsoft Norway. In this 4-episode interview series, you will hear from some of the brilliant minds who are pioneering in the machine learning space in Norway and making tremendous impact in their respective industry. Today in this episode, we have Luca Gary from DNV. So Luca, can you say a few words about yourself?
Sure. To begin with, thanks to you, Xiaopeng. Thanks to Microsoft for having me here. It's a great pleasure. So about myself, my name is Luca. I come originally from Italy, from a small town, the northern part of Italy, to be more precise, Busalla. I moved to Norway a while ago. It's about a bit more than 10 years now, so quite a bit. I can speak some Norwegian. But there is still a pretty way to go for me to become fluent, I'm afraid. Anyhow, I'm married and the father of 2, and we live in the center of Oslo. So on a personal note, I love biking, jogging, and more generally, walking out and about. That's pretty much, keeping myself active and out in the open space. It's really what, reinvigorates me or gives me, so to say, stamina and energy. Now, on a professional note, I'm a maritime engineer by training, and with time, I've grown more into projects that are mostly, data-driven, and so to say, more broadly into the data science domain.
Really cool. So right now you work as a principal data scientist at DNV.
Yes.
Maybe you can tell us, what that means, and also maybe a few words about your, day-to-day work and your team.
Yeah, I would say I'm really fortunate to work, here at DNV, which is truly a great company for someone like me who loves, both data and data science and the engineering domain, if you will, because I have a background from those domains. So here in DNV, I get the chance to work on projects which encompass both domains, both the data-driven knowledge domains and aspects, as well more the classical domains of engineering. And throughout these projects, I get the chance to help our customers working on safety, security, sustainability issues that sort of place at the intersection between these different domains. So this is truly an exciting place to work. And since you're asking about my team, I think it's fair to say that the team kind of mirrors a bit this variety. I have colleagues who are experts in data quality, colleagues who are experts more in sensor technology and sensor-based data capturing technologies. Some have a background in engineering, like me. Others are more into ontologies and knowledge systems, and others even focus on building just IT infrastructure, for instance, using the Azure stack, for example. So really, a varied, competence across the team.
Yeah, that's really exciting because, data science is really a team sport. So it definitely requires, interdisciplinary collaboration with people from diverse backgrounds. And sounds like, you have that already within the team. So that's really
absolutely great. And that's really those interface that you realize you can generate value, right? Because you sort of challenge one another, and that's really when, by challenging you're taken to the next level, if you will. And that's really when we generate value for the company, obviously for our customers as well.
Absolutely. So you mentioned that you were trained as a maritime engineer, but then now you work as a data scientist and work with machine learning. So how did that start? When did you begin your journey with machine learning, so to speak?
Yeah, it was a while back, frankly speaking. So my first exposure to data science in general, and then to machine learning more specifically, dates back to my early days in academia, if you will. Already back then, as a master degree candidate, I would model so-called Bayesian networks. These are essentially graphs which encompass representation of knowledge. I'll try to be to explain what I mean. So in simpler terms, you can, by using Bayesian networks, you can model variables and their interactions probabilistically. And that's really where my interest started, for data-centric approaches, which is something which I've nurtured, throughout my career. So now the interesting thing about Bayesian network is that you can use them also, so to say, as a data-centric approach. So you will use it as a classical machine learning approach, if you will, whereby you essentially train the network on, on a bunch of data, or even following the other paradigm, using an expert-first approach, which essentially means that instead of using data, you can encode or prescribe some of these probabilistic relationship, so to say, manually, if you will. So you can represent knowledge that may sit in your brain, your mind, but it's not necessarily found in the data. And that's really, I think, where Bayesian networks were certainly interesting for me, because you would get kind of the best of the two worlds, if you will.
Yeah, so that's where you started with machine learning. So when did you decide that you want to be a data scientist?
Oh gosh, I'm not sure it was something I decided. I found myself more and more working with data and especially trying to capture relationships in the data that weren't necessarily easy to describe, with the pen and paper, if you will, right? So in that sense, I guess by exposure and further involvement in these type of projects, I sort of find myself wearing the hat of a data scientist more and more often. So this is pretty much what my journey has been, really a transition into the domain, if you see what I mean.
Yeah, absolutely. So I mean, you have a PhD in maritime engineering, and then you also worked as a postdoc researcher for a couple of years. So after your transition from the academia into the industry, so what would you say is the main difference when it comes to researching about machine learning and practicing machine learning in the industry?
Yeah. Broadly speaking, doing research is really about trying your best to kind of falsify your initial hypothesis. So what I mean here is that typically in a research setting, you start with an initial statement, a hypothesis, and then you work your way through, the data you have. You may have some experiments to generate data. You may even develop, a new theory, or you derive a new equation or improve equation and whatnot, while continuously sort of wrestling with this notion that you may come across findings that would not necessarily support your initial hypothesis, your initial statement. In that sense, you're sort of falsifying what you started with, in the first place. And when you're in research, you just have to appreciate that. You just have to, be open to the fact that this can be the case. It can truly be. You can truly find yourself in a situation where, having spent some time doing some research, all of a sudden you realize, what I initially thought was the case, now these findings seem to, point to the contrary. And I guess this is key in machine learning too. I sometimes in my work now come across, groups who have grown fond of their own models and development, and rightfully so. But perhaps they also need a bit more of a healthy attitude, if you see, towards their own work, and kind of being a bit more inquisitive or curious and start questioning the results they get. So is this model working because it truly captures the dynamics of the problem train model, or maybe is it perpetrating some spurious things, some correlations, if you will, that are found in the data, but perhaps is falling short of truly describing the problem, if you see what I'm trying to say. So I guess that sort of, inquisitive attitude that you learn to apply in research carries over very well and effectively so in a machine learning context, where you are continuously trying to, stress a bit the boundaries of your model and try to assess the quality of your own work.
So when you transition from academia into an industry setting, I assume the cycle between research and development into application is now shorter compared to when you were back in the research domain, right? So how does that affect the way you practice machine learning?
Well, first and foremost, it's true. And what I would say, the practice is way more team-centric than in research. In research, in the end, this is very much, there are some notable exceptions to it, of course, but at least according to my experience, the rule is that you as an individual, researcher, PhD candidate, whatever, you would essentially work your project from end to end. You may have some interactions with, colleagues, but the norm is essentially that you're supposed to work alone, and what you produce is really the results of your own work. These dynamics obviously totally shift that wouldn't really, succeed in a professional context or environment where you are supposed to, first and foremost, really to optimize your own work. So to do the best for, limited set of resources within time constraint and boundaries and, project lifetimes. And also really being able to play each other in a positive way. So I bring to the table some competence, some strong points. I expect you as a team member to do the same. Maybe we don't necessarily overlap, hopefully so, and we are able, to find the right synergies to produce good work. So this is pretty much I guess the main difference I really see. It's not very much on the concepts of machine learning per se, or the theory or anything. Is really about the way you work. And sometimes you just have to be content with what you do and say, okay, I may not have the ability to go into every single details of my work because this is not just doesn't make sense in the context of a business situation I'm in. But you will have to also trust others that will do their bit, and together you can deliver value for for within certain boundaries.
Yeah, absolutely. So I guess what I took away from your elaboration is that the fact that you are working in a more collaborative environment in an industry setting actually help accelerate the way you practice machine learning, right?
It does, and especially allows you also to compartmentalize a bit, if you see what I mean. So you sort of start, having some areas where you can grow more experience, and divide and conquer pretty much. So I would, I may take care in a development project. I may take care of some aspects of the model. I'm making an example, model training. I have colleagues who are very strong on data quality and building pipelines for data quality. So that part in the pre-processing, or even just building up the the IT infrastructure is needed to follow and ensure quality and maintain quality in the data will be their domain. And in that sense, that kind of changes a bit the dynamics again, because you're no longer supposed to take care of the end-to-end, where you can specialize into just one given spot.
Yeah, makes sense to me. So you mentioned data quality. So on that note, you also said before that no machine is more intelligent than the data fed to it. So can you expand on that one?
Obviously, this is something I firmly believe in. Since I think lately much of the hype around machine learning focuses mostly on the modeling aspects. And sometimes the data is sort of not properly taken into the picture. So I'm far from saying that models do not matter, but I believe that the quality of machine learning system really puts the data and the data quality front and center. So if you think about it, the data represents the world to a machine learning algorithm. It's really an algorithm will see the data, and that's pretty much all it gets to see. And if the data is a distorted version or representation of our real world, then the model will learn and perpetrate that distorted version. So if you have issues with data, such as class imbalance, unfairness, other issues, the model will simply perpetrate those issues in the way it functions. That's why I think a proper balanced approach towards quality machine learning really starts with the data and asking some questions about, do we have the right data? Does the data truly represent the elements I want to capture in my model? Does the data truly represent the effects that will affect my decisions and will allow me to come with an objective assessment of a certain situation the model is supposed to represent?
Yeah. I'm gonna ask a very difficult question here.
Yeah.
So, I mean, obviously, sometimes the bias in the data can be inherited in the model, right? As you mentioned. But we also know we live in a world, that is biased in some aspect of our life. So when we develop a machine learning system that is going to reflect, the world that we live in. So what is your thought around, representing the world with fidelity versus representing a world that's more ideal, that's less biased?
It's a difficult question. I believe I don't want to get into the details because this is really a sensitive topic. But I think for some applications, we really want to portray and push ourselves towards a better version of ourselves. So in that sense, I'm open to see developments that may not represent the reality around us as we see it, but we'll try to achieve a more balanced and objective in how can I say perspective. And there are some applications in the in societal domains that I think speak volumes as to the need to remove bias in the data, obviously, and if present in the real world as well. And
Yeah.
I leave it at that. I hope that that answers your question.
Yeah, absolutely. I mean, I think this is one of the questions that everyone can have an opinion about, and everyone can debate with each other. But I do appreciate you sharing your insights on this one.
And that is truly my own personal opinion, by the way.
Yeah,
So yeah.
of course, of course. Good disclaimer. So you work with the machine learning assurance at DMV. I think for some folks, this is actually a new term. Can you tell us what that means in practice?
Yeah. So with machine learning assurance, you're essentially asking yourself, is the quality of this model good enough to justify its use in the context that I'm planning to use it? Yeah. How does the work in practice is? It is not rocket science in the end. I mean, there are some fundamental rules that help a lot in going about and checking the quality of a machine learning model. We have encoded some of these rules, a great deal of these rules, I would say, into a recommended practice. Recommended practice is essentially one of our publications, one of a set of documents that we routinely publish to help certain sectors standardize practices and provide a bit of understanding of the state of the art in certain applications of interest. So we've done that for instance, machine learning and data science. We have the recommended practice framework for assurance of data-driven algorithms and models, what we typically call as recommended practice 510, because that's kind of the nickname. And there you will see pretty much, how this could work in practice. So we have a number of phases in a data science project, and every phase will have a number of requirements that are typically seen to be relevant in in a project involving data and machine learning. So I would recommend and suggest whoever may be interested to see how this works in practice to go and have a look at our recommended practice. But I think it's fair to say that it really starts with the understanding from the end users about model and how that model can help improve their decision making. So I think it really what's important here is to check how the model is going to be utilized, and above all, if the end users are capable of interpreting the results from the systems in order to have that objective decision making that we were just discussing, I guess, a couple of questions ago.
Yeah.
And that's really crucial to quality in machine learning.
Absolutely. I think that's an extremely meaningful piece of work. So I do recommend folks to check out the recommended practices from DMV on machine learning assurance. So let's move on to the next question. So obviously, you have good history working with data science and machine learning. So I wonder, what's your perspective on running machine learning on the cloud? So what are the main benefits of doing machine learning in the cloud?
Yeah, certainly, scalability, the possibility for stronger and tighter team collaboration, transparency internally, and overall, oversee on data sources, versioning of data and models. We use, for instance, Azure. As you know, it's our corporate cloud solution. We are very satisfied with this, with it. And DMV is using Azure as the platform for machine learning, as well as other analytics services that we develop and provide. When it comes to my experience working with the Azure platform, I'm personally very pleased and satisfied. I can make an example which dates just a few weeks back. I can't go into the details because it's because of confidentiality, but I developed, there was a need to develop a monitoring service for data quality, because like I said, data quality is an important piece. And that monitoring service itself was using a machine learning element. So that was, it's pretty interesting. But anyhow, using Azure Data Factory, I was able to, to essentially develop and deploy the service fairly quickly. So the time to production and to value was extremely short.
Yeah.
And that, to the pleasure, of course, of my own pleasure, of course, but also the pleasure of the stakeholders in the project, which really saw value in, how fast we were able to tackle what was thought initially to be an objectively difficult application. We were able to tackle within the within very, very reasonable time.
Oh, that's really music to my ears. So let's end on one last question. So I always ask the same question to the other to the other machine learning pioneers as well in this interview series. So what does it mean to you to be a machine learning pioneer?
Yeah, being a machine learning pioneer essentially means being in an environment which is pioneering and which helps you push the boundaries, challenge yourself, and really trying to improve on your own work, which is what I find in DMV. I'm fortunate enough to be surrounded by colleagues who are very competent in their own domains, and that helps me to focus on some specific applications, which is really, giving me the opportunity to use that as a differentiator in a sense, and being able to become better at certain elements of the machine learning pipeline, if you will. So in that sense, like I said, being machine learning pioneer means being surrounded by people who are as pioneering as you, if you will. Without that, I don't think I'll be able to keep up with the quality of work that we pride ourselves to deliver.
That's a really humble answer, I have to say. But Luca, let me put it this way. I think the focus, your focus around machine learning assurance and also responsible machine learning is really inspiring, and it really help us move forward as an industry. Towards better use and more responsible use of machine learning. So I think that's something that we have to give kudos to yourself, but of course, DMV as a company. So with that, I want to wrap up this session, and I want to thank you again, Luca, for joining me today.
Thanks to you, Xiaopeng, and to Microsoft again. It's been a real pleasure. And thank you.
All right. I also want to thank the audience for joining today, and hope to see you in other episodes. Take care. Bye-bye.
Bye.